Okay, so we're going to prove that A intersection B intersection C is equal to A intersection B intersection C for any sets A, B, and C. Okay, so basically what we're showing is that intersection, right? The operation intersection among sets is associative. So let's go ahead and start the proof. Okay, so we're going to have X be an element of A intersection B intersection C. So by definition, this means that X is an element of A and X is an element of B intersection C. And by definition again, we know that this is X is an element of A and uh, X is an element of B and X is an element of C, right? So we can see this is of the form P and Q and R, which we know is logically equivalent to P and Q and then and R, which I will show in a second with this statement. So, because of the logical equivalence of what we're going to do, we know that this is the same thing as X is an element of A, and X is an element of B, and X is an element of C. We know that P and Q and R is logically equivalent to P and Q and R. So that's what we're using here to go from this statement to this statement, right? Okay, so we know this is, by definition, X is in A and X is in B means that X is in A intersection B and X is in C, right? And then by definition one more time, we know that this means that X is an element of A intersection B intersection C, right? So we have X is an element of A intersection B intersection C if and only if X is an element of A intersection B intersection C. So we have that for every X is an element of A intersection B intersection C if and only if X is an element of A intersection B intersection C. So what this tells us is that these two sets are in fact equal to each other. So this means that A intersection B intersection C is equal to A intersection B intersection C. And that's what we set out to do. We set out to show that these two sets are equal, aka showing that the operation intersection between sets is associative. And that is the proof.